Season 3, Episode 2. Last episode, RAG let the model actually use your data. This episode, we climb up one more level. The agent platform. These days, the word agent gets hyped into something almost mystical, like the model suddenly grew a mind of its own. Let me rip that mystique right off for you. An agent, when you get right down to it, is just a while loop around an LLM. Plus, the ability to call tools. The model decides what to do next. The loop goes and executes it, feeds the result back to the model, and goes around again until the task is done. That's simple. So what is an agent platform? Here's the one line I want to weld into your brain today. The intelligence lives in the model you rented. And the vast majority of the platform is guardrails that keep this loop from hurting you. It's not agent magic. It's the seatbelt, the roll cage, and the flight recorder. Let me be clear up front about why a single loop is worth building a whole platform around. In a single question and answer, all the model can do is answer. But the moment you give it tools and let it loop, it can actually take action. Query a database, send a request, write a file, run a multi-step task. The power goes up, and all the new headaches come right along with it. It'll hallucinate, it'll get stuck spinning and burning your money, it'll fat finger a database delete, and every run takes a different path, so you can't reproduce it. I'm not just trying to scare you. There really are teams where an agent got stuck in a loop overnight, and they woke up to a 4-figure bill. And there really are agents that took files that were supposed to be archived and just deleted them. The platform is there to manage these 4 things, giving it tools, memory, a cost gate, a sandbox, and tracing. We'll run through them one at a time, for real. First, let's look at the loop itself, today's main character. The task is simple. My 3 accounts, A, B, and C, how much money is in them altogether? If you just ask the model straight up, no tools, no data, what happens?
It makes up a number that looks about right, 3,500. The truth is 4,100 and change. It never actually looked at your real balances. That's a hallucination.
Now switch it over to the agent loop. The model doesn't answer directly. It decides. First, check A's balance.
The loop calls the tool, pulls back the balances for A, B, and C one at a time, and feeds them back to the model. The model decides again. Add these 3 up. It calls the add tool. Exact, down to the penny.
Look closely. Same model. The only difference is that while loop and the tools it can call. The loop grounds the model in real results, instead of letting it make things up with its eyes shut. This pattern has a name. It's called react. Think a step, act a step, see the result, then think the next step. And notice that one-shot mistake, you can't fix it by swapping in a bigger model. What it's missing isn't brains, it's data. And what the loop hands it is exactly that, data. A real-world scenario. A customer service agent handling where's my order has to call the lookup tool first, then the shipping tool, one step at a time. This decide, act, observe, decide again loop is the agent itself. Everything else is just guardrails around it. The first guardrail. Memory. The context window is limited. On a long task, there's no way you can carry every single turn along, word for word. And what hurts even more, every model call is billed by the token. The more history you carry, the more every single step burns money. Let's run a 20-turn conversation. On the first turn, we tell it an account number, and on the 20th turn, we need to use it.
Option 1, carry it all. By the 20th turn, 4,000 tokens, over budget, and every single call pays for all of it. Option 2, keep only the last 6 turns. Smaller, sure, but that account number from turn 1 rolled out of the window a long time ago. It forgot what you told it at the very start. Option 3, a rolling summary catches the gist, and you retrieve the relevant turn back on demand. Cheap and nothing forgotten.
Did you catch that? This third option is just RAG from last episode. Except what you're retrieving is the agent's own history. An agent's memory is, at its core, retrieval-augmented generation over its own past. Tell the two apart. The handful of turns right in front of you is working memory, like a sticky note. What you drop into the vector store is long-term memory, like an archive room. And summarizing isn't deleting, it's squeezing 10 turns down into one line. Customer is returning an item, account number ACC 4021. The gist stays, and if you want the details, you can still look them back up. The second guardrail, and the most critical one of all, the cost gate. Remember, every time this loop goes around, it's spending real money. Every model call gets billed. So for an agent, the scariest failure isn't getting the answer wrong at all. It's the agent getting stuck, spinning in place, quietly burning your money, until somebody finally notices. Let's simulate one. A tool goes down, the model has no idea, and it just keeps deciding to retry it.
With no guardrails, it just keeps retrying. 1,000 calls in, $30, still going. In production, this is burning all the way until the billing alarm goes off.
Add the guardrails. A step budget, a cost cap, plus a loop detector. Same action 3 times in a row, abort right there.
3 calls, 9 cents, stopped.
That's about 300 times the difference. And the key thing is, it fails loud. It tells you why it stopped, instead of silently draining your account. Why is an agent especially dangerous? Because it checks all 3 boxes. Non-deterministic, able to act on its own, and it costs money. A wrong answer only makes you pay once. A spin with no cost gate keeps on paying until the moment you notice. So the cost gate isn't optional. It's a fuse you plug in the second you power on. Steps, cost, loops, set one gate on each of the 3 dimensions, and whichever one hits its line first is the one that stops it. The last guardrail, and this episode's honest card. Sandbox, approval, and tracing. Because the model is non-deterministic. Give it a pile of real tools, and sooner or later it'll propose a dumb one, or a dangerous one. The key move. Grade your tools by risk. The read-only ones, search and read underscore file, can run automatically. The ones with side effects, deleting, paying, sending email, have to go through an approval gate. Let's run one. The model's plan has a database delete step slipped right into it.
With no sandbox, whatever it decides just runs. The database delete executed. The mass email went out. 1 token comes out wrong, and it's a disaster. Add the sandbox. Search and read underscore file, the 2 safe ones, run automatically. Delete underscore records and send underscore email, the 2 dangerous ones, get blocked and held, waiting for a human to approve.
And notice that whole string just now. Which step, what action, what risk, how the gate ruled, all of it recorded. That right there is observability. A non-deterministic run you can't reproduce. Without this trace, there's no way you can debug it. It's the agent's flight recorder. Think about why this is harder than a traditional system. An ordinary function, same input, same output, you can write a unit test to catch it. An agent, same sentence, takes 3 steps today, 5 steps tomorrow. You can't even test it. So all you can do is lean on guardrails as your backstop and on the trace to review afterward. Let's run the 4 questions.
What it helps with. It upgrades the model from only answers to can take action. Calling tools, orchestrating multiple steps, remembering across turns. What it replaces. One-shot question and answer gets replaced by a loop plus tools. Stringing steps together by hand gets replaced by the agent orchestrating itself. What it changes. The system's center of gravity shifts from a single inference to a loop with guardrails.
So where's the line? Here's the honest card. Hold on to it. An agent is just a while loop around an LLM plus tools. That simple. It's non-deterministic, and it'll do something dumb eventually. So about 80% of the engineering in an agent platform is guardrails. Sandbox, approval, cost gate, memory, tracing. Not some kind of agent magic. The intelligence is the model you rented. The platform is the seatbelt, the roll cage, and the flight recorder around it. Don't mistake the guardrail's job for something the model handles on its own. Before we wrap, a few pitfalls. 1. Don't treat the agent like magic. It's just a loop plus tools, designed for that, or you'll end up losing your mind over it. 2. With memory, don't cram in everything, and don't keep only the most recent. Let a summary catch the gist and add retrieval to fish back the few key ones. 3. You absolutely have to have a cost gate. Step budget, cost cap, loop detector, you can't skip a single one, or one night it'll burn you a sky-high bill. 4. Dangerous tools have to go through the sandbox and approval. Deleting, paying, sending mail, never let a non-deterministic model pull the trigger directly. 5. Leave a trace on every single step. Something you can't reproduce, with no trace, is just a black box you can't debug. Let me weld one line to close it out. An agent platform equals a loop around an LLM, wrapped all over in guardrails. The intelligence is in the model. The engineering is in the guardrails. And once again, you can see it's all old parts inside. A queue for async subtasks, a cache to block repeat calls, a vector store as memory, rate limiting as the cost gate. AI native systems, down to the bone, are still system design. Next episode, we drill into the heart of this loop, how the model itself gets served up efficiently. Designing an LLM inference service. Continuous batching, KV cache, multi-tenancy. See you next episode.